for the question 1, given the following function fx equal to 2x power 4 minus 11x power of 3 plus 17x power of 2. So part A, find the critical number of fx. Find the first derivative using the power rule. Power move to the in front times 2 and then get 8x power minus 1 get 3 and minus 30x power of 2 and plus 34 times x. And then critical point using fx first derivative equal to 0. So 8x power of 3 minus 30x power of 2 plus 34x equal to 0, and then factorize, get x bracket 8x squared minus 30x plus 34 equal to 0, and then factorize the inside and then get x equal to 0, x equal to 17 over 8 and x equals to 2. So the critical number of the function is x equal to 0, x equal to 17 over x equal to 2. And then part B, the point of which function has relative extremum. From the first derivative, find the second derivative using the same method, and then get 24x power of 2 minus 60x plus 34, and then substitute the critical number x equal to 0 and then get 34 greater than 0, which is relative minimum, and then substitute 17 over 8 and then get greater than 0, relative minimum, and substitute the 2 x equal to 2 and then get minus 2 less than 0, get relative maximum. So therefore relative minimum at 0.00 and relative minimum at 0.17 over 8 11.99 and relative maximum at the 0.24. For the part C, the interval on which fx is increasing or decreasing. Using the first derivatives, create the table. An interval starting from minus infinity to the 0, 0 to 2, 2 to the 17 over 8, 17 over 8 to the 11 infinity. So using the any point at this interval and then get minus 0, substitute at the first derivative and then get minus 0, decreasing and increasing, decreasing and increasing. And then part D, plot the graph using the GeoGebra. Open the GeoGebra and then insert the function 2x 4 minus 11x power of 3 and plus 7x square, and then get the graph.
Now we move on to question number 2. First step, from the question we can draw the diagram of the rectangle and we interpret the length as x and the width as y. From the question we know that dx over dt is equals to 2 and the area is 50 inch squared. And we know that to find the area of the rectangle, the formula is x times y. So from this, we can know that xy is equals to 50. Next, the information that we can get from the question is perimeter is equals to 2x plus 2y. Since this question asks for rate of change, so everything will be divided by dt. Now the third step, the question asks for the rate of change of the parameter. So dp over dt. So the formula that we need to use is this formula. We already have dx over dt and we don't have dy over dt. So how to find? We have to use product rule. From xy equals to 50. So use product rule, du prime plus dx over dt is 2. We can substitute 2 dy over dt. So for the next step, we can substitute dy over dt that we calculate just now. dt. The question asks when x equals to 5. xy equals to 50. We substitute x as 5. Now substitute x equals to 5 and y equals to 10 into our dp over dt. So we get the answer is -4. Conclude that at 5 inch, question asks for when x equals to 10. Do the same as question A just now. Substitute x as 10. We get y equals to 5. We get the answer is 2 by 2 inch per second. The parameter ceases to decrease, which means it will stop moving when its rate is exactly 0. So in other words, when dp over dt is 0. So we already know our dx over dt, which is 2. So we substitute 2 and dy over dt be the subject. Now we can use this formula and equate with the -2 that we calculate just now. Divide it by -2 equals to 1, or we can rewrite it as x equals to y. We know that x times x equal to 50, which means x squared equals to 50. Be 5 square root 2 or equivalent to 7.07 inch, which means the parameter will stop decreasing when the rectangle becomes a square.
For question number 3, the question is the total cost of producing X ratio set per day is Rm 1 over 4x squared plus 35x plus 25, and the price per set at which they may be sold is Rm 50 minus 1 over half x. Question A, what should be the daily output to obtain the maximum total profit? In this question, we were asked to find the daily output that give maximum total point. Profit is defined as revenue minus cost. So our goal is to maximize the profit function. Step 2, we need to express all the function in one variable. First, we need to find the revenue function. Revenue function is calculated by number of unit multiplied by price per unit. Now we substitute the function. Now we multiply it like usual, and then this will be our answer. Now we subtract the cost function to obtain the profit function in this question. Now we just minus all the question like usual. We need to remove the bracket and then just minus like usual, and this will be the answer. This is now a single variable function which is allow us to use calculus. Step 3, we need to determine the domain. Since x is represented by the number of ratio set produced, it cannot be negative. Therefore, the domain is x bigger and equal to 0. There is no fixed upper limit given, so we focus on critical point within this domain. Step 4 is to find the critical point. To find where profit is maximized, we take the first derivative of the profit function. Now we just differentiate it by using power rule. That's it. 2 multiple by 3 over 4, we will get 6 over 8, and simplify it, we will get 3 over 2x. X is because x minus 1 and will become a single x, and 15 x will be 15 because x 1 minus 1 is 0, and 25 because it doesn't have x, so it will be 0. Now we will set the derivative equation equal to 0, resolving the x, and then we will have the answer of x equal to 10. This is the critical point where maximum or minimum profit may occur. Step 5, we need to check for the maximum or minimum. Next we apply the second derivative test. When we differentiate it, this will be the answer. Now you just subtract x of x equal to 10 in the second derivative test, and then the answer will be this, negative 3 over 2. That's it, less than 0, and the answer, it is a maximum point. Conclusion is 10 ratios set per day give maximum profit. For question B, they ask us to show the cost of producing a set is a relative minimum at that output. To find the cost of producing one ratio, we set using average cost function. That's it, cost divided by x, one ratio set, and we just subtract the function, and we will get this when we simplify it by 1 over x divided by x, and just then step 2, we find the critical point. To find the critical point, we need to find the first derivative. When we find the first derivative, this will be our answer. This will be our answer, and then set the first derivative equal to 0 to find x, and the answer will be x equal to 10. Step 3, to confirm whether this is x equal to 10 is minimum or maximum, we find it using the second derivative test. When we differentiate it using second derivative test, we will get this as an answer, and we just subtract x equal to 10 in the x of the second derivative test, and the answer will be this 1/20. That's it. Bigger than 0, and the answer it is a minimum. Conclusion: the cost of producing one ratio set is at a relative minimum when x equal to 10 ratio sets per day. That's it for me.
Hi, Assalamualaikum and good evening. My name is Nur Shafiqah Badrisha binti Muhammad Bradley Shah. So now I will explain how to evaluate the following limits using L'Hopital's rule. So first, we have limit x approaching 0, sin 3x over 4x. First, we have to check the form of the limit. So as x approaches 0, 3x also approaches 0 and 4x also approaches 0, and this will give you 0 over 0, which allows you to apply L'Hopital's rule. So firstly, if the limit is indeterminate, you have to find the derivative of sin 3x and 4x separately, one by one. So to find the derivative, sin 3x will be cos 3x times 3. So this will be 3 cos 3x. Meanwhile, 4x will be 4. So this will give you 3 cos 3x over 4. When you get this form, just substitute x equals to 0 inside this, and cos 3 0 is equals to cos 0. Cos 0 gives you 0. I'm sorry, cos 0 equals to 1. So it is 3 1 over 4. So the final answer, the value of the limit is 3 over 4. So the next question is limit n approaches infinity, 3 e power of 2n over 4n squared. So this is also in indeterminate form, which will give you infinity over infinity. So we can apply L'Hopital's rule. So just like before, we have to find the derivative of 3e power of 2n and 4n power of 2. So this, to find the derivative, 3e, this will be 3e to n times 2, and 4n squared will be 4 times 2n. So this will give you the answer of 6e power of 2n over 8n. Since this is still an indeterminate form, so we apply L'Hopital's rule a second time. Limit n approaches 0, approaches infinity. So differentiate 6e to n times 2 will give you 12e power of 2n, and 8n will give you just 8. So you will get the final limit equals to limit n approaches infinity, 12e power of 2n over 8. So substitute the infinity inside the n, and therefore as the n approaches infinity, therefore the limit diverges into infinity. So the final answer is infinity. Thank you. So I will explain question 4, 3 Roman, lim x approaching 0 plus x square ln x. So here, lim x approaching 0 plus ln x over x to the power of negative 2. Because x to the power of negative 2, if we bring here, we will got x square. So we differentiate ln x, it will become 1 over x. And then we will differentiate x to the power of negative 2 using power rule. So x to the power of negative 2 we will bring in front like this, and then the power negative 2 minus 1, so we will got negative 3 over here. And then we will bring x to the power of negative 3 to the numerator, so x negative x cube over x. So x here cancel, 3 here cancel, become 2. So that's why x square over 2 and negative here. And lastly, we will sub 0 plus to the x here, and then we will got the final answer is 0. For question 4 for Roman, lim n approaching infinity n e to the power of 2n. So for this question, we don't need to differentiate. So firstly, we will do lim n approaching infinity n over e to the power of negative 2n, because if we bring it to the numerator, we will got e to the power of 2n. And then e to the power of 2n is actually positive infinity, because exponent is always positive, as n approaching infinity is n more than 0. So that's why we got positive infinity here, because exponent is always positive, as n approaching infinity is n more than 0. So that's mean e to n equals to e negative 2n equals to positive infinity. So it will become always positive. And then we already do this e to the power of negative 2n. We will got 0 plus, because 1 over positive infinity is 0 plus. Okay, so we sub infinity to n, so infinity here, then 0 plus here, so infinity over 0 plus, the final answer is infinity. 0 plus means 0 approach positive side, so that's what is 0 plus. And also 1 over positive infinity, so it's positive here, that's why 0 plus here. So that's all.